Here we have two vectors y and z. They are both vectors in R2. So 2, 1 transpose column vector 2, 1 and the column vector 1, 4 in R2. And the first question is, are they linearly independent? And yes, they are. And do they form a basis of R2? Yes. Two vectors in R2 are linear independent. Then they span R2. Therefore, because they have the same number of vectors as the dimension of the vector space. So yes, the first question is yes. They form a basis of the vector space R2. And the second question is the main one for this exercise. What is the coordinate of vector x with respect to this basis? So the basis contains two vectors y and z. To do that, we write x as a linear combination of y and z. And then the coordinate of x is that the scalar. The coefficient correspond to y and z. So here we have x equal to say ay plus b z. Suppose so a, b here are real number, and suppose we found a and b, then the coordinate of x with respect to the basics y and z is a, b. This is the coordinate. And since we are working with vector space, the column vector space R2, so I put transpose here. Okay, now we need to find the scalar a and b. And this is the coordinate of vector x in this basis with respect to this basis. So we have x is 7, 7. Vector 7, 7 equal to a times vector y, so 2, 1 plus b times vector z, 1, 4. This is so 2a plus b and a plus 4b. Yeah. System, two equations, two variables. This implies that y is equivalent to a equivalent to 3 and b is equivalent to 1. Yeah, so this is easy system equation. You can see the solution immediately. Otherwise, we can use Gauss-Jordan reduction, for example, to find the solution of the system. Okay, so the coordinate of x with respect to this basics is 3, 1 transpose. So now this order basics is important. So now suppose they ask us instead of y z but z y, then the answer would not be 2, 3, 1 anymore, but is it 1, 3 transpose. You can write down it here. If they ask us about the coordinates of x but with respect to z and y, so z is first, then it would be 3, 1, 3 transpose.